Hi, welcome to this video about problems with the RMSEA. If your RMSEA is too high, for instance above 0.10, one possible reason is that your model doesn't fit the data. But unfortunately, that's not the only possible reason. Another reason could be that you have only small degrees of freedom, and in that case, the RMSEA can give you seriously misleading results. This video will show you when this can happen, why this can happen, and what you can do about this. There are a number of popular fit indices for SEM, path analysis, and CFA, the CFI, the SRMR, and the RMSEA. For the RMSEA, there are different cutoff values in the literature, 0.05, 0.08, and 0.10 according to Brown and Kadek, or 0.06 according to Hu and Bandler. I think the RMSEA is popular because you get a confidence interval and you get a p-value for close fit, which you don't get for most of the other fit indices. However, there is a problem. In models with small degrees of freedom and not a very large sample size, you could get a bad RMSEA above those cutoff points, even for a correct model. Let's look at an example. I first stumbled upon this problem with this simple path model. I had two independent variables, one mediator, and two dependent variables. This model has 3 degrees of freedom, and I ran a simulation with this model. So I knew the data was produced by this model. This was the correct model. And here are the results I got when I ran a path analysis on this simulated dataset. The chi-square was significant. Okay, that's quite common that you have a significant chi-square. That's the reason why we have fit indices. The CFI was very good, 0.98, and the SRMR was extremely good, 0.01, but the RMSEA was catastrophic, 0.234, well above the cutoff values. So how can this be? This seems to be a common problem. The relevant source for that is Kenny, Keniscan, and McCoach, 2015. At least that's the version I've used. There are other versions of this paper from 2014. And the key statement by them is, for models with small degrees of freedom, the RMSEA can exceed cutoffs very often, even when the model is correctly specified. So if you have a model with small degrees of freedom, an RMSEA above the cutoff points doesn't tell you that you have a misspecified model. Why? For the RMSEA you have a parsimony correction. That is, for the same mean error, you get a worse RMSEA if you have small degrees of freedom. And in the calculation, the sample size is relevant too. So you get a worse RMSEA for low sample size. Now, what are small degrees of freedom and what is a not very large sample size? In the paper from Kenny et al., you'll find tables with their simulation results. So they have simulated for different combinations of degrees of freedom and of the sample size, how likely it is that even for a correct model, you get an RMSEA above the cutoff values. So there you can look up for your combination of degrees of freedom and sample size, how likely it is that you get a bad RMSEA even if your model is correct. So what's the solution to that problem? There's a recommendation by Kenny et al. For that. They're saying, don't even calculate the RMSEA with small degrees of freedom and small n. Instead, check alternative models with plausible additional paths. I don't necessarily agree with the first part of that recommendation. I think the RMSEA is more or less expected nowadays. So I would report the RMSEA in addition to the other fit indices. However, with small degrees of freedom and small n, I would reference Kenny et al. And make clear that in this case, the bad RMSEA isn't necessarily relevant. But I agree with the second part. You should check alternative models. How would you do it? Let's get back to our example. Here there are 3 plausible additional effects. We could add a direct effect from the independent variable 1 to the dependent variable 2. Or we could add a direct effect from the independent variable 2 to the dependent variable 1. Or from the independent variable 2 to the dependent variable 2. So I would check those 3 additional models. That is, this model with one of those 3 possible additional paths. And then check whether those additional effects are significantly different from 0. If checking those additional models doesn't show us that one of those additional effects is necessary, then we have shown that our model is okay, even though the RMSEA doesn't look okay. So that's it for dealing with problems with the RMSEA. If you like this video, make sure to subscribe to my YouTube channel. Just click on the subscribe button below this video. Thank you so much for watching.